All right, greetings everyone. Welcome to the fifth and final part of the videos for section 8.2. And we're going to finish this up by looking at converting between equations in both polar and Cartesian coordinates. So we've looked at, prior to this, graphing equations or functions in terms of polar coordinates. Now we're going to look at converting those back and forth between polar and Cartesian. And as we do this, we want to keep in mind these sets of formulas that we have here. They will be useful for us as we go through this. All right, so we're going to start by rewriting these Cartesian equations in polar form. So that means we need to go from using the variables x and y to using the variables r and theta. So we're going to start with the first one up there, the x squared plus y squared equals 3x. And again, we need to take this from x and y's to just r's and thetas. And as we look at this, you hopefully first of all recognize that this x squared plus y squared, we have an equivalence for that. That's the same as r squared. And then the x here is the same as r cosine theta. So what we'll do is just substitute that stuff in. So the equation will now become r squared, because that takes the place of the x squared plus y squared, equals 3 times r cosine theta. And then what we want to do, so now we've gotten rid of the x's and y's, which is good. We now want to take this to the next step and solve for r, because as you might recall, our polar equations are in the form r equals something. Now, you may be tempted to just divide out r from both sides, cancel it here, so then we'd have r equals. And it turns out in this case that'll give us the right answer. However, we don't want to be in the habit of that, because that is something that if we were solving for actual values of r or theta here, it's something that would cause us to lose solutions. So here's what we're going to do instead, is I'm going to move all the terms to the same side of the equal sign. So I'm going to subtract 3r cosine theta here, subtract 3r cosine theta here. Okay, so these will cancel. And then we'll have r squared minus 3r cosine theta equals 0. So we can't combine the r squared with those two things, because the r squared does not have a theta term with it. And then notice in both of our terms here, they contain r. So we can factor an r out. So this will become r times r minus 3 cosine theta equals 0. And we have two terms now being multiplied to equal 0. So we know we can solve this by setting each piece equal to 0. So we can do r equals 0 and r minus 3 cosine theta equals 0. And then on the right-hand side one, we can solve for r by adding 3 cosine theta to both sides. Whoops, did not mean to do that. And when we do that, we end up with these cancel. And on that right-hand side there, we'll have r equals 3 cosine theta. Okay. Now, the next question you might be asking yourself, okay, so we have r equals 0 and r equals 3 cosine theta. And hopefully it makes sense that not both of those can be equivalent to this equation up here. So we have to decide which one it is. And in this case, it's going to be the r equals 3 cosine theta. And the reason we know that is if you think about if we were going to graph the r equals 0 solution, well, that tells us that regardless of what the value of theta is, the value of r is 0. And so as we rotate around, we're going to be going 0 distance away from the origin, which means we're just going to have a dot at the center. And if you think about the graph of x squared plus y squared equals 3x, you may or may not be able to recognize that's an equation of a circle. And that's certainly not a circle if we just have a single dot. So that tells us that this r equals 3 cosine theta. That's our answer. And you could also graph that to see that that is a circle. Okay. All right, let's look at the second one then. So here we have y equals x squared. So we're again going to use our identities from the previous slide to make substitutions here. So we know for y, we can put up in r sine theta. For x, we can input r cosine theta, and that whole thing being squared. And if we simplify that some more, we have r sine theta equals, on the right-hand side, everything inside the parentheses is being squared. So we would have r cosine times r cosine. If we square both of those, that will give us r squared times cosine squared of theta. And then again, we could finish this by dividing by cosine squared and dividing r's on each side, but we're not going to do that because we'll lose solutions. So we're again, I'm going to subtract r sine theta from this side, and subtract it from this side. And so these will cancel. We'll just have 0 on that left-hand side equals r squared times cosine squared minus r times sine theta. Can again factor out an r here, so I have 0 equals r times r cosine theta, r cosine squared theta minus sine theta. We again have two things being multiplied, set equal to 0. So we set each part equal to 0. So we could have r equals 0, or we could have r times cosine squared of theta minus sine of theta equals 0. Can add sine of theta to both sides, which would give us r cosine squared theta equals sine theta. And then we divide by cosine squared on both sides. Okay, so on the left-hand side, these will cancel out. R equals sine over cosine squared. We can make that sine over cosine times 1 over cosine, right? Because the two cosines being multiplied in the denominator, that would give us the cosine squared. So you can check that those are the same, which then becomes r equals tangent of theta, since that's what sine over cosine is equal to, times 1 over cosine is secant of theta. Okay. And again, we have two possible answers here, r equals 0 and r equals tan theta secant theta. However, again, we actually know what the graph of this looks like, right? Y equals x squared is a parabola. So that r equals 0 will not work for that because that'll just be a single point. So our answer is, again, the second one, r equals tangent theta times secant theta. Okay, so that's converting from Cartesian to polar. Now let's look at going the opposite way, from polar to Cartesian. And I would say with these types of equations, really our main goal is to get rid of the r's and thetas, because often the equations we'll end up with will be really hard to solve for x or y individually. So let's look at how we would do this. So for the r equals 2 sine theta. Well, in our identities, there wasn't one that could easily give us a value for r. So we'll have to use, so we can't do anything with that yet. But we do have an identity, whoops, sorry. We do have an identity for sine. So we'll substitute something in there. Okay, so looking at those identities we had, we know that sine of theta is equal to y over r, so we can input that for sine. So we'll have 2 times y over r, which we can then multiply out there. We would have r equals, and the 2, we can make a 2 over 1, Multiply that by the y over r. The 2 times y gives us 2y. The 1 times r gives us r. So we have 2y, r equals 2y over r. And again, we're trying to eliminate any r's or thetas, and we got all the thetas gone now. So now we can multiply by r on both sides of the equal sign to get that r out of the denominator. And so we end up with r squared equals 2y, which if you're wondering why I just magically decided to multiply that r out of the denominator, hopefully you see now why we could do that. Because here on the left side, we now have r squared, which we know from those identities is the same as x squared plus y squared equals 2y. Whoops, not 2x, 2y. And so we can just then leave our answer like that. Okay, we don't need to go any further. And the reason we don't is because it'd be really hard to solve for either x or y in that equation. Okay. All right, one more example. So r equals secant of theta. And this one is going to take a little more finagling. So first of all, we know that secant is equal to 1 over cosine, which at first might seem like, okay, that's not helpful, Cody, because we're trying to get rid of r's and thetas. But it does get us going somewhere because we know, in this case, that cosine is the same as x over r. So now we have 1 over x over r, which means we're doing like there 1 over 1 divided by x over r, which we know means we're dividing with fractions, which means we keep the first fraction as 1 over 1 times. Second fraction gets flipped, so instead of x over r, it becomes r over x. And we multiply straight across, we end up with r over x. So right now we have r equals r over x, which doesn't look quite as friendly as our previous one. But we'll follow a similar process. We get that x out of the denominator by multiplying by x on both sides. So the x's cancel out. So we have x times r equals r. Can again follow the same process we've done before. We're not just going to divide out r, we'll subtract r on both sides. Okay, so when we do that, these cancel, and it looks like we end up with x times r minus r equals 0, which we can then factor out the r, so they give us r times x minus 1 equals 0. We can then set each piece equal to 0, so we could have, again, that r equals 0, which we know is not going to be correct. We have the x minus 1 equals 0, and solving that by adding 1 to each side gives us x equals 1. So the equation r equals secant theta is the same as the equation, Cartesian equation, x equals 1. Okay. All right, that's it for now. Thank you for watching.